All right, so I'm going to share the screen going to actually what the quiz is going to look like. So y'all should be seeing my chapter 2 quiz on your screen. So what I'll do is I'm going to go back and forth between this screen and my writing pad. So this is number 1 on the chapter 2 quiz. And number 1 wants me to convert 27 feet into inches. All right, so let me find one thing here. Also, let's go to the pad. Let's see. All right, so we want to turn 27 feet into inches. So what I'm going to use is that sheet that I gave y'all. But on y'all sheet, y'all should see I do have a conversion from feet to inches, and it's telling me that 1 foot equals 12 inches. So I know that 1 foot equals 12 inches. So that's going to be the only conversion I need on this one. So we're starting with 27 feet. Remember, the trick on this is to get your units that you don't want to cancel out and the units that you do want to be the only ones there. So since I got feet up top, when I write this conversion, I need my feet to the bottom. So 1 foot is going to equal 12 inches. So notice now I got 1 foot on top, 1 foot on the bottom. They're going to cancel out. So y'all, for this problem, we just got to multiply 27 feet by 12.
324.
324, and that's now in inches. So we got 324. So you would go back to the math lab and punch in 324. All right, then you just click next and go to the next one. So let's see what number 2 is wanting here. So number 2 wants me to convert 15 years into hours. So 15 years into hours. And they're telling us, don't worry about leap years. So neglect the leap years, okay? So back to the pad to do our work. All right, y'all, so we're going to convert these 15 years into hours. Now, I don't have a conversion from years to hours on our sheets, but you could figure that kind of stuff out. But what I'm going to do is go from years to days, and then from days, I can go to hours. So I do know that 1 year has 365 days. And then when I want to go from days to hours, I know that 1 day is 24 hours. All right, so first I'm going to cancel the years by using the days. So I need the year on the bottom. So 1 year is going to equal 365 days. So at the moment, we got our years to cancel. So now we need another conversion from days to hours. So I'm going to use this one. It says 1 day is 24 hours. I need the day to the bottom so it'll cancel. So 1 day is now 24 hours. So my days cancel. So it looks like we're going to multiply 15 times 365 times 24. So anyone got that one?
131,400.
131,400. And that is now in hours. So you expect really big numbers when you're going from years to hours because there's so many hours in a day and then so many days in those years, okay? All right, y'all, so let me remember that one so I can go put that one in. All right, so we said 131,400. All right, then you would hit next and move to number 3. Okay, y'all, so this one says a race has a distance of 24 furlongs. They want to know how far is that in miles, in yards. So how far in miles, and then how far in yards. All right, they're telling me type of integer or decimal, so they don't really want fractions on this. They just want those decimal answers. So y'all on your sheet that I gave y'all that day, you should see a conversion up here that says 1 furlong is 40 rods, or it's 1/8 of a mile. So since we want decimal answers, I'm going to figure out what 1/8 is in decimal form. And in decimal form, that would be 0.125 miles. Okay, so it's easier to use these decimals instead of these fractions when you're doing these little formulas. So that's my conversion. 1 furlong is going to equal 0.125 mile. And we started with 24 furlongs. So we're going to write 24 furlongs. Now, y'all, I'm not for sure, but furlongs, I think, is a distance that they use on horse racing. It seems like when you watch like Kentucky Derby and stuff, they'll say the horse is so many furlongs ahead of another horse. So I think that's where that lingo comes from. All righty, y'all, what did we say? We're going to use a conversion that says 1 furlong equals 0.125 miles. So remember, we need the furlongs to cancel, so I'm going to put the 1 furlong on the bottom. And that's going to be 0.125 miles. So notice my furlongs are going to cancel. So I'm going to end up in miles like I want. So basically, you're just going to multiply 24 times 0.125. Or if you like fractions, you can multiply 24 times that 1/8. So let's see, 24 times 0.0125. What did y'all get?
3 miles.
There you go, 3 miles. So we went from furlongs to miles. Now they want me to figure out what that is in yards. So what I'm going to do is I'm going to start with the 3 miles and convert my 3 miles into yards instead of starting back with those furlongs. So let's see on here, you're going to see one up here that says 1 mile is 1,760 yards. So that's going to be my conversion. So 1 mile equals 1,760 yards. So we're starting out with 3 miles, remember? So 3 miles. For every mile, so for every 1 mile, that equals 1,760 yards. So my miles are going to cancel. So I'm going to be left with yards. So y'all, we need to multiply to 3 times 1,760. Ooh, so it looks like I'm getting what, 5,000 280. And that is now in yards. So y'all, let me pause here and see if y'all have any questions on these first three problems. So I'm gonna go put these answers in real quick. So we said the first one was what, 3 miles? And then the second one was 5,280. All right, so moving on to the next one. All righty, so this one's sort of tricky, but let me write down what we got. You can fill 12-gallon tank, so 12-gallon tank for, what's that, $40.99. Or you can buy gas for $3.20 a gallon. So they want to know which of these two prices is the better deal, and we're going to explain why. So let's go figure out which one's going to be the better deal. Now, really, what's nice on this problem is one of them's giving you a price, $3.20 per gallon. So what we got to figure out on this is whether that 12 gallons for $40.99 is a better deal or not. Okay, so to figure that out, I'm going to take this $40.99 and we're going to divide that by how many gallons we had, and we had 12 gallons. So once we divide that out, that'll tell me how much per gallon we're actually paying for this gas. So y'all take that $40.99, divide by 12, and I'm getting 3.415, so I'm going to make that 3.42 to the nearest cent. And that is also per gallon now. All right, y'all, let me let some in real quick. So I've got Alex Bradley and Olivia Johnson. All right, y'all, hang on just a second. I got to figure out who's in here. Alex Bradley is showing on the screen. I don't have that name in my class. So who is this?
It's Jasmine. My phone died.
Oh, Isabel. Okay, okay.
Yeah, sorry.
Oh, you're right. They just make us verify who's coming in for y'all's HIPAA rights and all that fun stuff. All right.
Yeah, I didn't know she was logged in. I'm sorry.
You're good. So $3.20 a gallon was one price. When I figured it out for the $40.99 for 12 gallons, I got $3.42 a gallon. So for this one, it would actually be better to get gas at $3.20 a gallon. So let's go see how they want you to write this answer. So you'll stop that. We'll go back to the screen with the math lab. All right, so let's see. The better deal is to fill the 12 tank for $40.99. Well, we said that wasn't the best deal. So let's see. The better deal is to buy gas for $3.20 a gallon, because the price to fill the 12-gallon tank of gas for $40.99. Well, let's see. On that one, we ended up with what, $3.42 a gallon? So you put in that 342 that we figured out per gallon, and then you move to the next question. So it's tricky. So A and B aren't two different questions. They're the two different answer choices, okay? All right, number 5, let's see. Okay, this is the one about the apartments. So let me write down the info they're giving me. So for Monte Carlo is 10 square meters. And you're getting that for 1,250 euros. Then it says Santa Fe. Santa Fe is 600 square feet. So 600 square feet. And you're getting that one for $950 a month. All right, so notice in terms of price per area, which apartment is less expensive? Now, notice that both these answer block boxes are saying per square foot. So what we really want to do is turn the European euros and meters squared into American dollars and feet squared. So the American one's going to come out all right because we got American money and feet squared. So what we're going to work on is the Monte Carlo. So I'm going to start with 1,250 euros. And we're paying 1,250 euros per 10 meter squared. All righty, so you're going to have conversions for the money on here, but instead of clicking the link, I'm just going to go to the conversions for money. So we're looking at European euros. So when you want to turn foreign money into American money, you use the dollars per foreign. And that's telling me that for every euro, it is worth 1.058 American dollars. Okay. So y'all, you're going to use the same conversion that I'm using because every one of these is dealing with euros. Okay. So first let's work on that and then we'll work on the meter squared stuff. So we said for every 1 euro, that was 1.058 American dollars. So we're going to cancel out the euro. So the euro has to go to the bottom. So 1 euro is 1.058 American dollars. At the moment, I can cancel out my euros so that now I'm left with American money. But what we got to now figure out is these meter squareds. So we're going to need another row here. So let me go back to the sheet here. Now you don't have meter squared stuff on here, but you do have one that tells me that for every 1 meter, that is 3.28 feet. Or you could use this one that says 1 foot is 0.0348 meters. Either one of them will work. So what I'm going to do is just use the one with the 1 meter equals 3.28 feet. So 1 meter equals 3.28 feet. But y'all noticing one thing. This is meter squared and feet squared. It's not meters and feet. So what we got to do is square both of these so that we can get the ratio we need to go from meter squared to feet squared. So I'm going to square both sides. So 1 times 1 is going to stay 1 meter squared. On the right side, I got to multiply 3.28 and square that. So that's going to be 3.28 times 3.28, which is going to give me 10.7584 feet squared. So you take the basic units they're giving you and you square both sides on that one. So that's going to be the conversion I'm going to do, is that 1 meter squared is 10.07 0.7584 feet squared. So meter squared's on the bottom. So my 1 meter squared has to go to the top. And for every meter squared, it is 10.7584 feet squared. So y'all notice now the meter squareds are going to cancel. So I'm going to have dollars per feet squared, which is what we needed on this one. So what you do, multiply 1250 times the 1.058. I'm going to start out by doing 1250 times 1.058. That's giving me 1322.5. And then you're going to divide by both of these numbers on the bottom. So I'm going to divide by 10 first. And then I'm going to divide by the 10.7584. So everything on the top row gets multiplied, and then you divide by everything on the bottom row. Y'all, when I do that, we're going to round this to the nearest cents. So I'm looking at the 29 behind this, a 2. So I'm going to leave that $12.29 per foot squared now. So we got what we needed, dollars per square feet. So what we're going to do now, so this is Monte Carlo here. So Monte Carlo. We're going to now figure that out for Santa Fe. But look, Santa Fe gave me $950 per 600 feet squared. So sort of like the one with the gas. Since they've already given me money per feet squared, I'm just going to divide that and see what that ratio gives us. So we got $950 divided by 600 feet squared. So I'm getting a 1.583. So I'm going to keep that at $1.58 per foot squared. All right, so let's look at that. Monte Carlo cost me $12.29 per foot squared. Santa Fe cost me $158 per foot squared. So Santa Fe is definitely the least expensive. Well, okay, so let's see how they want us to put that one in. All right, so we're just putting in amounts. So the Monte Carlo apartment cost, we said Monte Carlo was $12.29. The Santa Fe apartment we said was $158. Therefore, the apartment in Santa Fe is least expensive. So y'all, how's that? And that's a little tricky, right? But here, you see these blue links up here? Click here to view the UCS, the metric. If you click that one, that one gives you one with the links. And then the second one says, click here to view the currency. Click that one, it gives you the currency rates. But if you got that sheet, I emailed y'all the helper sheet for the conversions. You've got everything on there for this one, okay? All right, so let's see. What do we want to do? Hit next, and we're going to number, oh, what was that? 5? It is 5, so it should be giving me number 6. All righty, y'all. So this one we have $4 for sedans and $5 for trucks. So this is a toll collector on the highway. They get $4 for sedans and $5 for trucks. At the end of a 2-hour period, they collected $104. Then it says, how many sedans and trucks passed through the toll booth during that period? So notice we got 10 choices. So what we got to do on this is multiply each of these sedans by 4, the trucks by 5, and see if that gives us $104. If it gives us $104, then it is a choice that we got to pick. So y'all, let's start out with A. 6 sedans and 16 cars. So we need to multiply 6 times 4. Add that to 16 times 5 for the trucks. So 6 times 4 plus 16 times 5 gives me $104, which is what we needed. So you're going to click A. Then you're going to do B the same way. 12 sedans, so that'll be 12 times 4 plus 11 trucks, so that'll be 11 times 5. Add those two amounts together, I got 103, which means B is not an answer. C, 1 sedan, so that'll be 1 times 4 plus 20 trucks times 5. That gives me 104, which is a correct answer. So we're going to click C. D is 22 sedans and 3 trucks. So that's 22 times 4 plus 3 times 5. When I punch that in, I got 103. So that means D is not an answer. All right, so E was what? 2 sedans. So 2 times 4 plus 19 trucks will be 19 times 5. Woo, when I push that in, I got 103. So E is not an answer. So about half of these will probably be answers and half won't. So let's see, 16 sedans, so that'll be 16 times 4 plus, oh, what is that, 8 trucks, so that'll be 8 times 5. When I punch that in, I got 104, so F is an answer. So G is what, 21 sedans, so 21 times 4 plus 4 trucks times 5. Punch that in, I got 104, so G is a good answer. Well, y'all, let's see, H, 26 sedans, so 26 times 4 plus 0 trucks. So that gives me 104, so H is a good answer. All right, y'all, 2 to go. So this one says 0 sedans, 21 trucks. So that'll be what, 21 times 5 for the trucks. I got 105, so I is not an answer. So let's look at J. 11 sedans will be 11 times 4 plus 12 trucks will be 12 times 5. Punching that in, I got 104, so J is a good answer. Now I'm going to tell y'all on this one, I could have narrowed this down to which one of these answers it was had they told me how many vehicles passed through the toll. So like if they'd have said, oh, we had 22 vehicles, we know it was A. 21 vehicles would have been C. 24 vehicles would have been F, and so on, okay? All right, so we got all of our choices. We click next to go to the next question. So this will be what, number 7. Oh, this is the one with the pipe. So let me write down what info they're giving me. They're telling me 8 turns of wire. My pipe is 60 inches long. And my pipe has a circumference of 4 inches. All right, so I'll read this out. Suppose that 8 turns of wire are wrapped around a pipe with a length of 60 inches and a circumference of 4 inches so that the wire reaches from the bottom of the pipe to the top. So they want to know what is the length of the wire. So what is the length of the wire? And they're telling you as a hint, picture cutting the pipe along its length and pressing it flat. So I'm going to go to the pad and work this one. All right, so let me draw what they sort of got going on. So here's my pipe I'm going to draw. So I do know that from the end to the end here, this pipe is 60 inches long from end to end. I also know that the circumference is 4 inches. Are y'all familiar with the circumference? So I don't hear that.
Pi 3.14? Probably wrong.
Oh, you're doing too much thinking on that. So the circumference, when you hear the word circumference, they're asking you how far it is around a circle. So the circumference they're telling me is 4 inches. So that means that this pipe, if you put a tape measure and went around it, that would be 4 inches. So pi is the ratio of the radius to the circumference. So that's where y'all was getting that 3.14, okay? So y'all check this out. I got 8 turns of wire. So this wire is going around my pipe 8 times. So I actually drew my pipe a little long, but that should be coming down right into that corner there. So they went around it 8 times. So what they said, hey, cut this pipe along its length and press it flat. So if you did that, so I'm just cutting it and pressing it flat, you would have 8 lines coming down like this. Okay. We know that this side right here was that circle when we pressed it flat. So if the circumference is 4 inches, that means that that side right there is definitely 4 inches. Now, y'all, do you see what they got going on? They want you to realize that if you drew lines down each one of these, you got a bunch of triangles in here. And all we're going to do is focus on one of these triangles. I got one side of that triangle, which is 4. So what I need to do is see if I can figure out what this little side of that triangle is going to equal. So what I did to that, I said, well, hey, this bar was 60 inches long, and I wrapped that wire around 8 times, they told me. So to get each one of these little sides, you're going to take that 60 inches and divide by the number of turns we had. So since we had 8 turns, we would take that 60, divide by 8, and I get 7.5. So that means each one of these little sides is 7.5 inches. And if you took that and added it up 8 times, that would equal back to my 60. So let me draw this, what I got. I've now got a triangle sitting here. A right triangle.
Wait, just a sec. You said that side is 7.5 inches?
Uh-huh.
And the one that's bigger than it is 4 inches?
Yeah, but remember, I'm not drawing mine to scale.
Okay. Okay,
Yeah, 60 inches would have took me, what, 5 feet to draw that?
right. Okay,
So yeah, so had it been to scale, this side would have been a little bit longer.
okay, thank you.
Mm-hmm. All righty, you got two sides of a triangle. This is a right triangle. So we can always use to find the third side Pythagorean theorem. So the Pythagorean theorem tells us that a squared plus the b squared is going to equal the c squared. The only requirement on this type of problem is that that longest side right here has to be your c. Now, when you're doing this problem, it don't matter what a and b are, but c definitely has to be the longest side. And remember, c is always what we call the hypotenuse. It's always the side right across from that right angle, which is always going to be that longest side. So y'all, what I need y'all to do now is plug in 4 for your A, plug in 7.5 for the B, and you're going to square both of those, and that's going to equal C squared. All right, so on your calculator, 4 times 4, what's that, 16? 7.5, someone square that one. So if you square that, are y'all getting 56.25? And all that's going to equal C squared. So to square that 56.25, are y'all familiar how to do that? So let me go back to my calculator to show y'all that in real quick. So over here on the left side, you see a button that looks like an X squared. When you want to square stuff quick, you can hit your number 4 and then hit that X squared button and see how it makes that little exponent up there. So now it's telling me it's going to do 4 squared. And that's where I got my 16. Then I had to do 7.5 squared. So I'm going to do 7.5. I'm going to hit that X2 button again on the left side. That's going to square it. And when I hit enter, I got 56.25. So that's the quickest way on that calculator to square something, okay? All righty, next, it says add those. So you're going to add 56.25 plus 16. That should give you 72.25 equal to our C squared. All right, but remember, that's a C, that's not a C squared. So to undo a C squared and turn it into a C, you got to take a square root, which means you got to take a square root of the other side. So the square root of C squared is just going to give you a C. So on your calculator, I think y'all can see this one. Right above that X squared key is a blue radical. That's for square roots. So to get that, you would hit the blue button and then the X squared button, and it's going to put that radical on your screen, and then you punch in 72.25. I think that's what I had right there, right? Yeah, 72.25. So now it's going to take that square root, and it gives me 8.5 equal to the C. So we now know this long side is 8.5 inches. So what can I do now to figure out the total length of this wire? All right, y'all, so think about this. We know that that one side is 8.5 inches. But how many of those did we have? Well, up here it said we did 8 turns. So there's going to be 8 of these wires around that. So you need to take that 8.5 and multiply by the 8. All right, so let's see what we get. 8.5 times 8, I'm getting 68, which means that wire is 68 inches long. So y'all good on that one? That's the tricky one. So you're going to work this out the same way I did. You're going to have your circumference is going to be one of the sides. They're going to tell you how long is your pipe, and you're going to divide that by how many turns to get your other side. All right, that's going to have two sides of a triangle. You're going to solve it for the third side. Once you got that third side, to get the total wire, you need to take whatever you get on the third side and multiply by those turns. Okay. So you sort of got to divide by the turns to get the length of the side, but then multiply by those turns to get that total wire. All righty, so let me go. I need to go back to the math lab. And my wire, I think we said was 68. So I'll punch in my 68. And then we go to number 8. And I think there's only 8 questions on this. So this will be our last one as far as this quiz goes. So each of 10 large barrels is filled with golf balls that all look alike. The balls in 9 of the barrels weigh 1 ounce, and the balls in 1 of the barrels weighs 2 ounces. With only one weighing on a scale, how can you determine which barrel contains the heavy balls? So, look at these possible answers. So this one says, select 1 ball from the first barrel, 2 balls from the second, and so on, up to 10 balls from the 10th barrel to find the weight of a specific number of balls in a specific barrel. This one says, weigh all the balls from all 10 barrels to find an average weight of the balls in all 10 barrels. Well, that might not work because remember, one of them barrels is full of heavy balls. And if we get an average of all of them being done, then it's not really going to tell us which one's the heavy balls. C says, weigh all the balls from 1 barrel to narrow down the selection of barrels. Well, if I do all the balls from 1 barrel, then I still got 9 barrels of balls. And D says, this is not possible. There's no way to determine which barrel contains the heavy golf balls. So what would y'all go with on that? So I think we've pretty much narrowed it down to A and D. So y'all, I'll tell you, the correct answer for that one is A. And I'll sort of show you what they got going on. So I'll go to that pad. So I got 10 barrels and I'm taking out 1 golf ball from the first one, 2 from the second, 3 from the third, 4 from the fourth, and so on all the way up to 10. So what they're saying, if I took out all these balls, I would have 55 balls. So what they're now telling me to do, if I take out 55 balls from the first barrel, I can weigh that against these 55 balls. I can do that to the second barrel, to the third. I can compare 55 balls to these 55 balls so that once I weigh them, if it's equal, then I know I'm using the heavy barrel. If it weighs 1 gram more, I know to use this one. 2 grams more, 3 grams more, and so on. Ever how many grams more than the 55 balls I got in any barrel that I'm picking, that's going to be my, oh, what would you call it? I'll know which barrel because I'll know how many more grams my balls are than the barrel I'm pulling them out of. If the barrel I'm pulling them out of weighs more than this, then I definitely got the heavy barrel. So, ooh, that's a tricky one there. But y'all, the answer on that one is always the choice about picking 1 ball, 2 balls, and so on. Okay. So yeah, that's a tricky one. I like the one better that had y'all remember doing the one with the 12 coins and you had to figure out which one of the gold coins was the heavy coin using 3 weighings. So I sort of like that one better, but they went with this one on that. So that'll be your 8 questions that are on this quiz, okay? So I'm going to shut this quiz off. And then stop that share. All righty, so did y'all have any questions on those 8 questions?
No.
All righty, so I will say this. I'm going to go back to the pad a second. So where's my share? Thursday night when we come in, I'm going to deal with the chapter 3 stuff. In chapter 3 is going to deal a lot of scientific notation. Y'all probably seen it a little bit, but I'm going to refresh y'all how to write numbers from scientific notation as regular numbers and how to do regular numbers as scientific notation. So let me give you one example. One example is 29 trillion. So hundreds, thousands, millions, billions, trillions. 29 trillion, that's our national debt right now. So I'm going to show you how to write this one as a scientific notation, and then I'll do one that's got a lot of zeros in the front. So to write scientific notation, y'all, the first thing you do, you got to move the decimal behind the first non-zero digit going left to right. Okay, now if you move left, so if I move left, then that means the exponent is positive. If I move right, that means the exponent is negative. So I'm going to move my decimal behind the first non-digit going left to right. At the moment on this number, it don't have a decimal. So where's the decimal?
Taking
So-
it that it's a whole number, will
Yeah,
we be
that's the
moving
whole
it to
number.
the, we'll be moving it to the, right? So,
Yeah, so my decimal is going to start out way over here on the right side behind that last zero. So watch what we're going to do. We're going to move it behind the first non-zero digit going left to right. Well, the first digit going left to right is a 2. So I need to move this decimal from over here all the way behind that 2. So we're doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I had to move my decimal 13 times. So what you do, you write the significant digits. Followed by times 10. So let's write the significant digits. All these zeros to the right of that 9, they're nothing but placeholders. So the only significant digits for this one is going to be the 2.9. And then we write that times 10. And here, you're going to put the exponent, and the exponent equals the number of moves. So what did we say? We did 13 moves. Remember, I moved it left. I went from the right and moved it left. So my exponent's going to be positive. So I would write my 13 as a positive exponent and be done. Final answer. So y'all, let me just do one of those with a really small number, and then we'll really work on these on Thursday, okay? This brings back memories though, right?
Yes, sir. It's been about 30 years.
Alrighty, so I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18 zeros followed by 2, 1, 5. This is the mass of a proton. And protons we can't even see, so they're very, very, very small. And we're going to convert this small number into scientific notation. So we said going left to right, we need to move the decimal behind the first non-zero number. So here we go. That's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. It took me 19 moves to get that decimal behind the first non-zero number, which was the 2. So this is going to be 2.15. And then remember, those are only significant digits because all these zeros are just placeholders. So we got 2.15 times 10. Oh, Lord, I forgot how many moves I did. I did 1, 2, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I did 19 moves. So the question is, since I moved the decimal to the right, my exponent will have what sign?
positive.
Oh, do the other guess.
Negative.
Negative.
Negative. Oh, what was that? Negative 19, I think I said. So y'all, let me show you. On big numbers and you move it left, it's going to be positive. So left is positive. This one I moved right, so it's negative. So if you got numbers that are less than 1, exponent's going to be negative, okay? All righty, y'all, so let me stop that share. All righty. Thursday, like I said, we'll come in, we'll do scientific notation, we'll talk about magnitude of numbers, and they're talking about billions and stuff like that. And we'll knock out that 3 stuff. So by the end of this week, you'll want to have everything up through 3 done. Your support for 3 and then the homework for 3. That'll be all due by Sunday, okay? Well, okay, y'all, any questions?